Hello everyone, today we will going to see some practice questions from the chapter Coordination Compounds. This is part 3. Let's start. Disclaimer which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of original creators and owners of these images. If you are the owner of any images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. This is our index slide. Today we will going to see some practice questions from question number 17 to question number 24. Let's start with the question number 17. Which of the following pairs represents linkage isomers? So we have to tell that from the options given, we have given some pairs. We have to tell that which pair show the linkage isomers or which pair are connected by the linkage isomerism. Options are copper NH3 4 PtCl4 and platinum NH3 copper Cl4. Palladium PPH3 NCS and palladium PPH3 SCN or cobalt NH3 NO3 SO4 and cobalt NH3 SO4 NO3 or platinum Cl2 NH3 Br2 and platinum Br2 NH3 Cl2. So you have to tell that which pair represents linkage isomers. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. So the correct answer is option B, that is palladium PPH3 NCS and palladium PPH3 SCN. So linkage isomers are formed due to the presence of ambidentate ligand. So if in any complex we have seen a ambidentate ligand, that means it will show linkage isomerism. We use this concept here. Ambidentate ligands are those ligands which can attach to the central metal atom through two atoms. Like for example, this NCS here and this SCN. They both are same ligands, but here in the first complex, the bond is between palladium and nitrogen. And in the second complex, bond is between palladium and sulfur. But the ligand is same. And this type of ligand, which can attach directly to the central metal atom by the two bonds with the two different atoms within itself, is known as ambidentate ligands. So you can see that in the palladium PPH3 NCS and palladium PPH3 SCN due to the presence of SCN, they show linkage isomerism, and they are linkage isomers due to the presence of SCN, which is an ambidentate ligand. Right, and thus our B option is the correct answer. Okay, let's move on to the next question. Question number 18. Match the following and assign the correct code. We have given a table here in which two columns are present. Name column 1 in which complex species are there, column 2 in which isomerism related to the complex species are present. The complex species are like cobalt NH3 Cl2 positive, cis cobalt En2 Cl2 positive, cobalt NH3 NO2 Cl2, and cobalt NH3 chromium Cn6. In the isomerism, we have given 5 types of isomerism: optical, ionization, coordination, symmetrical, linkage. We have to match the correct isomerism corresponds to the complex species, right? So options are A is for 1, B is for 2, C is for 4, D is for 5. A is for 4, B is for 3, C is for 2, D is for 1. A is for 4, B is for 1, C is for 5, and D for 3. Or A for 4, B for 1, C for 2, and D for 3. You have 10 seconds to solve this question. After that, we will see the correct answer. Let's see. So the correct answer is option D, that is A is for 4, B is for 1, C is for 2, and D is for 3. So if you see in the A, we have this complex cobalt NH3 whole 4 Cl2 whole positive. So it is showing geometrical isomerism as it is connected to the fourth point, which is geometrical due to the presence of two types of ligand in this complex. Right? Two types of ligand means ammonia and chlorine. Both the ligands are different types. So due to this, this complex show geometrical isomerism. In the second complex in B, cis cobalt N whole Cl2 whole positive, it will show optical isomers because it's non-superimposable mirror image relationship. Like this is the cis form of complex, another one will be trans one, so they both are the non-superimposable mirror image, and that's why they show the optical isomers, and that's why the given complex cis complex cobalt N whole Cl2 whole positive show optical isomers. That's why B is directly connected to first point, that is optical. In the C point, the complex is cobalt NH3 whole 5 NO2 Cl2. This will show ionization isomer due to its interchanging ligand from the outside the ionization sphere. So you can see that this is the ionization sphere, big bracket or square bracket. You can see inside it NO2 and NH3 ammonia are the ligands, and outside of it the chlorine is the anion attaching to it. So basically what we are saying that it will show ionization isomer due to the interchanging ligand. So this NO2 can go outside of the ionization sphere, and this chlorine will come to the inside, and due to this property of this complex, it will show ionization isomer. In the D point, we have the complex cobalt NH3 whole 6 chromium CN whole 6. It will show coordination isomer due to the interchanging of ligand in between two metal ions, in this case cobalt and chromium, from one coordinate sphere to the another coordination sphere. So there are two spheres. You can see there are two square brackets in which two different ligands and metal ions are present. Cobalt, chromium metal ions, ligands is ammonia and cyanide. We can interchange the ligand in between the two metal ions from one sphere to another sphere. Like this ammonia can come here at the place of cyanide, and cyanide at the place of ammonia. So from the one ionization sphere to the another coordination sphere, the interchanging of ligands can be happen, and due to this property, this complex will show coordination isomer, and that's why D is connected to our third point, which is coordination. Okay, and thus the D option is the correct answer. Okay, let's move on to the next question. Question number 19. The structure of which of following chloro species can be explained on the basis of DsP2 hybridization? We have given some chloro species in the options, and we have asked that which structure can be explained on the basis of hybridization of type DsP2. Options are palladium Cl4 2 negative, iron Cl4 2 negative, cobalt Cl4 2 negative, or nickel Cl4 2 negative. You have 10 seconds to solve this question. After that, we will see the answer. Okay. Let's see. So the correct answer is option A, that is palladium Cl4 2 negative. So in the palladium Cl4 2 negative, the oxidation state of palladium is +2. If you see that in this complex, if you find out the oxidation state of palladium, let's suppose it is X. So X minus 4, because -1 for the one chlorine, but it is 4 ligands of the chlorine, so it will be 4 times -1. So X minus 4 is equals to -2, because the whole charge on the sphere is -2. So X minus 4 is equals to -2, X will become +2. So palladium oxidation state will be +2. So palladium in +2 oxidation state is having this configuration, that is krypton 4d8 5s0. If you write it in the form of orbitals, it will be this. 4d8, 8 electrons will fill according to the rules, and then 5s and then 5. Right? Although Cl negative is a weak field ligand, but in case of palladium Cl4 2 negative, the electrons of palladium are paired up. Okay? Because of its large size and results in dsp2 hybridization. So what we are saying that we know that Cl negative is a weak field ligand. Weak field ligands means that if any unpaired electron is present, it will get paired. It will not be able to get paired up, right? But in the case of palladium Cl4, it is an exception. In the case of palladium Cl4 2 negative, the electrons of palladium paired up. So this unpaired electron will get paired up. So this unpaired electron will go here and it will pair up like this, and this will become empty. This orbital will become empty. So the electron will pair up because of the large size of palladium, and it will result in dsp2 hybridization. You can see one orbital of d, s, and p2. So dsp2 hybridization. And in all the other cases, the pairing is not possible because of the chlorine, because it is a weak ligand, because of weak ligand chlorine. So hybridization will remain sp3 with the tetrahedral structure, which is associated with the sp3 hybridization in all other cases. But here in the case of palladium Cl4, it is an exception. Due to the large size of palladium, the unpaired electron will get paired up, even though at the presence of chlorine negative, which is a weak field ligand, and it will show dsp2 hybridization. And this is the question, that which structure can be explained on the basis of dsp2 hybridization. So PD, that is palladium Cl4 2 negative, is the answer. Thus option A is the correct answer. Okay, let's move on to the next question. Question number 20. Both nickel CO whole 4 and nickel CN whole 4 2 negative are diamagnetic. Both are diamagnetic. The hybridizations of nickel in these complexes are respectively. So we have to tell that what is the hybridization state of nickel in the both complexes. Options are sp3 and sp3, sp3 and dsp2, dsp2 and sp3, or dsp2 and dsp2. So you have 10 seconds to solve this question. After that, we will see the answer. Let's see. The correct answer is option B, that is sp3 and dsp2. So if you see the first complex, which is NiCO whole 4, the oxidation state of nickel will be 0, because the oxidation state of carboxy or monocarboxy CO, the oxidation state of CO is 0, and that's why the Ni oxidation state will be 0 in this complex. So Ni is having 28 atomic numbers, so its electronic configuration will be, noble electronic configuration will be argon 3d8 4s2, and this will be the orbital filling configuration, 3d8 4s2 and 4p here. So CO, carbon monoxide, is a strong field ligand. It is a strong field ligand, causes pairing. Okay. So in the presence of strong field ligand, we know that pairing will happen. Thus, this unpaired electron will get paired here. This will go here. So it will get this, and this empty orbital, this 4s will come here. Okay. So we get this empty 4s and this empty 4. So we can add the carbon monoxide ions or electrons to these 4 orbitals. So this will be S and P3. So sp3 hybridization. In the nickel CN whole 4 2 negative, the oxidation state of nickel is +2. Because for the cyanide, the oxidation state will be -1. -1 times 4 will be -4. So x minus 4 is equals to -2. So x will be +2. So nickel oxidation state will be +2. Now nickel in the +2 state show this electronic configuration, noble gas electronic configuration, that is argon 3d8 4s0 and this will be the orbital configuration. So 3d8, 8 electrons will fill, 4s and 4p. Now cyanide, Cn negative, is a strong filled ligand. Again, it will cause pairing. So all the unpaired electron get paired up, and this remains empty. So it, this will go here. This will go here and become this. And this will become empty. So dsp2. So it will show dsp2 hybridization. Okay. So what we have to do, we have to find out the nickel hybridization, both the complex. So in the second complex, it is showing dsp2 hybridization. In this first complex, it is showing sp3 hybridization. Thus, option B is the correct answer. That is sp3, dsp2. Now let's move on to the next question. Question number 21. Which of the following facts about the complex chromium NH3(6Cl3) is wrong? So we have given some statements, we have given some facts in the options, and we have to tell that which facts or which statement is false regarding this given complex. Options are: the complex involves D2sp3 hybridization and octahedralism shape, or the complex is paramagnetic, the complex is an outer orbital complex, the complex gives white precipitate with silver nitrate solution. These are the four statements. You have to select the wrong one which do not suit to this complex which is given in the question. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. So the correct answer is option C, that is the complex is an outer orbital complex. So this is the complex chromium NH3(6Cl3). This is the coordination sphere. Okay, and this chlorine, 3 chlorine, which is present outside of the coordination sphere, is ionizable. Okay, because inside whatever the species or the ions or the ligands is inside the coordination sphere, that cannot be ionizable. But outside that, whatever is present as an ion or cation, it can be ionizable. So the reaction will happen. So chromium NH3(6), 3 positive plus 3Cl negative, reacts with AgNO3 silver nitrate, gives white precipitate as AgCl. Okay, and if you see the chromium in the 3 positive state, it is having this noble gas configuration, that is argon 3d3 4s0. If you draw the orbital, it will be this 3d3, 3 electrons, 4s0, 4p0. Right? So you can actually see that it is having D2sp3 hybridization. Okay, D2sp3. It indicates that lone pair of ammonia are donated to chromium. So according to A's option, D2sp3 hybridization, that means octahedral structure, which is connected to the D2sp3 hybridization. It is shown by the D2sp3 hybridized molecules. So this is correct. So the statement is correct. According to the B option, there are 3 unpaired electrons, hence paramagnetic. You can see there are 3 unpaired electrons while filling the orbitals. You can see here that chromium 3 positive is having 3 unpaired electrons, hence it is a paramagnetic in nature. Thus, the second statement will be also correct. So C option, D2sp3 inner orbital complex. You can see that it is D2sp3 hybridized. So that means it is inner orbital complex. Right? It is inner orbital complex. Outer orbital, it is not, because for the outer orbital, it should have sp3d2 hybridization. Okay, but it is D2sp3. So it is inner orbital complex, but in the C option, it is given that it is outer orbital complex. Thus, the statement will be incorrect. And according to the D option, due to ionizable chlorine negative ions, white precipitate with the AgNO3 we have just observed Thus, this fourth statement will be also correct of the precipitation of AgCl while reacting the AgNO3 with this given complex. Right? So you can see that all the statements are correct except option C. And thus, the C option is the correct answer because we have to find out the wrong statement, which is option C. And thus, option C is the correct answer. Okay, now let's move on to the next question. Question number 22. Which of the following is diamagnetic? Options are iron Cn whole 6 3 negative, cobalt OX whole thrice 3 negative, iron F6 3 negative, or cobalt F6 3 negative. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. So the correct answer is option B, that is cobalt oxalate whole thrice 3 negative. We have to tell which is diamagnetic. So Fe3 positive and cobalt 3 positive, both the ions have unpaired electrons in their ground state. But strong field ligands like Cn negative, oxalate, if present, pair up the unpaired electrons and resulting in diamagnetism. So in iron Cn negative whole 6 3 negative, Fe3 positive. Fe is having 3 positive. 3 positive as a oxidation state. So the configuration will be 3d5 4s0. So you can see this is the 3d5 diagram, right? All the electrons are unpaired electrons. But because the Cn negative or the cyanide negative is the strong field ligands, that's why they get paired up. And in cobalt oxalate whole thrice 3 negative, CO3 positive will be having this electronic configuration. So this is the orbital configuration. You can see that 6 are the number of electrons which can be filled here, and because oxalate is a strong field ligand, so they will get paired up. So this is the final orbital state because all the electrons are paired. Also, after pairing, there is one observation that there is one unpaired electron left in FeCN whole 6 3 negative, but there is no unpaired electron left in the cobalt oxalate whole thrice 3 negative. Thus, cobalt oxalate whole thrice 3 negative is a diamagnetic species, we can say, as all the electrons are paired in it. Right? You can see here, cobalt 3 positive, after pairing up, all the electrons are paired. And in the FeCN whole 6 3 negative, the electrons, even after pairing up, if you paired up, it will come here. So it will become here. This will get empty. This will go here. So it will become this, and this will also go here. This will become like this. So this will remain as unpaired electron. Okay. So that's why only the diamagnetic magnetism is shown by this complex. And thus the option B is the correct answer. Okay, now let's move on to the next question. Question number 23. NiCl2P, C2H5 whole twice, C2H5 whole twice exhibit temperature dependent magnetic behavior, either paramagnetic or diamagnetic. The coordination geometries of Ni2 positive in the paramagnetic and diamagnetic states are respectively. We have to tell the coordination geometries of Ni2 positive in both the magnetic behavior states. Options are tetrahedral and tetrahedral, square planar and square planar, tetrahedral and square planar, or square planar and tetrahedral. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. So the correct answer is option C, that is tetrahedral and square planar. So in the given complex NiCl2P, C2H5 whole twice, C2H5 whole twice, nickel is in +2 oxidation state. If we find out the oxidation state of nickel, it will be +2. Now, nickel +2 will show this orbital configuration, right? And as the ligand attached to it is Cl, so the pairing will not happen. So it will show sp3 hybridized orbitals. So at the low temperature, for the given 4 coordinated complex to be paramagnetic, it must possess unpaired electrons in the valence shell, right? The geometry of paramagnetic complex must be tetrahedral and has sp3 hybridized orbitals. On the other hand, at the high temperature, for the complex to be diamagnetic, there should not be any unpaired electrons in the valence shell. This condition can be fulfilled by pairing the electrons of θ orbitals, and the geometry of diamagnetic complex is square planar and has the dsp2 hybridized orbitals. Right? So dsp2 hybridized orbital or dsp2 hybridized molecule is having square planar structure, and sp3 hybridized molecule is having tetrahedral structure. That's why the nickel in the +2 state and in the paramagnetic and diamagnetic will show tetrahedral and square planar geometry respectively. Thus, our option C is the correct answer. Okay, now let's move on to the next question. Question number 24. The magnetic moment spin only of nickel Cl4 to negative S. Options are 1.82 bm, 5.46 bm, 2.82 bm or 1.41 bm. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option C, that is 2.82 bm. So in NiCl4 to negative, the oxidation number of Ni nickel is X is equals to +2. And nickel is having 28 atomic numbers, so the noble gas configuration will be argon 3D84S2. But for the Ni2 positive, this will be the orbital configuration 3D84S04P0. And 3D84S04P0, that means we have only 4 orbitals in which we can fill the electrons of chlorine. So we have 4 sp3 hybrid orbitals, that is tetrahedral geometry. Okay, and chlorine negative is a weak field ligand, thus unpaired electrons are not paired, they remain unpaired, and lone pairs from the 4 Cl negative are accommodated in 4 sp3 hybrid orbitals, and thus the nickel Cl4 to negative has 2 unpaired electrons. As you can see here, it have 2 unpaired electrons, so N will become 2. Unpaired electron will become equal to 2. Magnetic moment spin only will be calculated as under root N times N plus 2. N is unpaired electron, so it will be 2. So 2 times 2 plus 2, that means 4 times 2, that means under root 8, which is having a value of 2.828 bm, which is equivalent to 2.82 bm. Right? And thus our correct option is C option. Okay. Thank you.